If the point pi over 2, negative 2 lies on the graph of f of theta equals a cos theta minus pi over 4 minus 4, find the value of a. We know the point pi over 2, negative 2 exists on the graph. Plug in pi over 2 for theta and negative 2 for f of theta. This gives us negative 2 equals a cos pi over 2 minus pi over 4 minus 4. Add 4 to both sides and subtract the radian fractions to get 2 equals a cos pi over 4. Cos pi over 4 evaluates to root 2 over 2. Cross multiply. Divide both sides of the equation by root 2 to get a equals 4 over root 2. Rationalize the denominator. Multiply the numerator and denominator by root 2. Multiply the fractions. Simplify. The value of a is 2 root 2. In part B, find the y-intercept of f of theta equals negative 3 cos k theta plus pi over 2 minus b. To find the y-intercept, set theta equal to 0. Simplify. Cos pi over 2 equals 0. Simplify further to get negative b. The y-intercept occurs at the point 0, negative b. Now we'll move on to part C. The graphs of f of theta and g of theta intersect at the point mn. Find the value of f of m plus g of m. Bring up the graph showing f of theta and g of theta. F at m means what is the y value of function f when x equals m? When x equals m, the y-coordinate is n. This is written as f at m equals n. G at m means what is the y value of function g when x equals m? When x equals m, the y-coordinate is n. This is written as g at m equals n. Now evaluate f at m plus g at m. Both f at m and g at m are equivalent to n. Add to get the answer 2n. Now we'll move on to part D. The graph of f of theta equals k cos theta is transformed to the graph of g of theta equals b cos theta by a vertical stretch about the x-axis. If the point 5 pi over 6, negative 3 root 3 k over 10 exists on the graph of g of theta, state the vertical stretch factor. Start with g of theta equals b cos theta. Plug in negative 3 root 3 k over 10 for g, and plug in 5 pi over 6 for theta. Cos 5 pi over 6 equals negative root 3 over 2. Isolate b by dividing both sides by negative root 3 over 2. Multiply the numerator by the reciprocal of the denominator. Simplify. Reduce the fraction to get 3 over 5k. We can find the vertical stretch factor by dividing the amplitudes of each graph. The vertical stretch factor is the amplitude of the transformed graph divided by the amplitude of the original graph. The amplitude of the transformed graph is b, and the amplitude of the original graph is k. The value of b is 3 over 5k. The k's cancel, giving us the vertical stretch factor 3 over 5. This is the answer.